Okay, we are live. Please go ahead.
Honorable guests and dear colleagues, Assalamu alaikum and welcome to the 13th Annual Undergraduate Research Experience Program Competition 2021. This is Noor Naimi, a member of the capacity building team from QNRF, and I will be your MC for today's event. I would like to begin by thanking all of you for taking out the time to be present here with us today. In particular, a very special welcome to our talented young researchers who are participating in this year's competition. Qatar National Research Fund launched the Undergraduate Research Experience Program 15 years ago and have been holding the UREP competition for the past 13 years. We organize this event every year to celebrate the success of exceptional research projects enabled through QNRF support and to encourage the future generation of scientists and researchers in Qatar. I am sure that the presentations today by our contestants will be an excellent learning opportunity to us all and will provide a window into the thriving research ecosystem fostering in the universities and colleges in Qatar. Ladies and gentlemen, please join me in thanking our expert judges for the oral presentations. The judging panel comprises renowned leaders in their fields who are leading Qatar's research and academic sector to a new era of development. The judging panel evaluating the oral presentations today include the chair of the panel, Dr. Michael Bendick, Provost of Hamad bin Khalifa University, Dr. Khalid Fakhro, Chief Research Officer at Sidra Medicine and the Director of the Healthcare Facility Precision Medicine Program, Dr. Adina Al-Thani, Assistant Professor at Hamad bin Khalifa University, and Dr. Mohammed Saif Al-Kawari, Director and Senior Engineering Consultant at the Ministry of Municipality and Environment, and Dr. Nader Qabbani, a Senior Fellow at Brookings. We thank you all again for joining us today and for your valuable contribution towards this competition. I will now would like to invite Dr. Abdel-Sattar Al-Ta'i, Executive Director of QNRF, to deliver his welcome remarks and declare the 13th Annual Undergraduate Research Experience Program Competition open.
Thank you, Noor. Bismillah ar-Rahman ar-Rahim. Distinguished guests, member of the judging panel, faculty members, and students. Assalamu alaikum and a very warm welcome to this 13th Annual Undergraduate Research Experience Competition. Today, I'm personally very thrilled to be attending this competition as it takes me back 15 years, exactly this month, when we started off as a small team with a huge responsibility on our shoulders, the responsibility to develop a thriving research ecosystem in Qatar, which by the grace of Allah, we have proudly succeeded in. From the onset of QNRF's journey, we knew that our students, especially at the undergraduate level, will be critical to the success of our mission. As we paved the way for the establishment of a flourishing research culture in Qatar, we needed sustainable supply of bright and talented minds to bring our research centers and laboratories to life and help our country progress towards the realization of its aims. Guided by this realization, the first program we launched after the foundation of QNRF was the Undergraduate Research Experience Program, or UREP for short. Our statistics say that we had 27 cycles, 1,160 research projects funded, 1,042 completed projects, and 4,700 and 60 participants, and still counting. Ladies and gentlemen, we have gathered here today to celebrate the achievements of yet another cohort of our undergraduate researchers. I congratulate all of the participants who have qualified for this year's competition, and I'm looking forward to their presentations. Winners or not, all students participating today will have the distinction of joining a vibrant UREP alumni community who are contributing to the development of societies worldwide. We are happy that we played a part in helping them pursue their research interests. It is pleasing to know that several awardees of previous UREP cycles have gone to pursue flourishing careers in research, development, and academic sectors, and are now themselves mentoring undergraduate students. In fact, one can say that we have come full circle, as this year some of the judges joining us were once themselves recipient of UREP funding and our other capacity building awards. Along with helping our students pursuing their research interest, UREP also gives undergraduate an opportunity to develop a unique and rewarding relationships with their mentors, being a former students and later a mentor to various students at different levels. I want to stress that this is a very valuable relationship and encouraging you, and I encourage you to make the most out of it towards your professional development. Dear colleagues, this year we have had a total of 31 teams competing for the UREP awards. These students are representing 4 universities in Qatar, and I congratulate all participating institutions today, and will also take the opportunity to thank them for their continued support to us in fostering a flourishing research ecosystem at the undergraduate level in Qatar. During the previous cycles of UREP, we had seen some exceptional research projects which have gone to receive recognition beyond Qatar as well. I am sure that this year too will get to see unique and innovative projects that aim to address the foremost challenges and identify valuable opportunities in Qatar, the region, and internationally. In closing, I would like to thank all the participants and the primary faculty members for their dedication, innovation, and their belief in UREP programs and its mission. Moreover, I'm grateful to all our guests joining us today and cheering our young researchers. Moreover, we are deeply grateful for the guiding vision of our leadership, whose relentless support in helping us to enable research excellence in Qatar since the past 15 years. I wish all participants best of luck, and I hope you all find today's competition an engaging learning experience. Thank you and God bless. To you, Nora.
Thank you, Dr. Attai, for your speech and recounting the circumstances surrounding the genesis of the Undergraduate Research Experience Program. Dear colleagues, this year we have 26 poster presentations and 4 oral presentations from participants representing 4 different universities in Qatar, including Georgetown University in Qatar, Qatar University, Texas A&M at Qatar, and Cornell Medicine-Qatar. I congratulate all the participants for qualifying for the finals and wish you all the best of luck in the competition. As Dr. Attai said, making it to the finals is an achievement in itself, for which all of you deserve credit and congratulations. Distinguished guests and our participants, without any further ado, we will now begin with the oral presentations. Each team has 15 minutes to deliver their presentations and 5 minutes for the Q&A session conducted by our judges. For the first presentation, I want to invite the team from Georgetown University in Qatar to present their project titled Investigating the Resilience of Qatar's Trade Network. Dear Alicia, can you please share your presentation as the floor is yours?
Sure, thank you. I'm just going to go ahead and share my screen quick. All right, good morning, everyone. My name is Alicia Kamran, and I'm part of Georgetown University's class of 2018. I'll be discussing our research study investigating resilience into Qatar's trade network, and we'll be doing this in 4 parts. First, I'll discuss the motivation for this study, followed by our methodology. Thirdly, our results, and lastly, our next steps. Our study into the resiliency of Qatar's trade networks was motivated by the recent events of the 2017 blockade. In the past, and in courses around international trade, there have been studies into the impact of trade bans. However much unfortunate and close to home this blockade was, it did provide students like myself and Halak, our second student researcher, with a unique opportunity to apply what we had learned in the classroom to study the impact of a real-world event. There were 3 main research objectives if we look to the left-hand side of the slide. The first was to evaluate the risk in Qatar's trade network, for example, by identifying which countries Qatar relies heavily on for imports and exports. This could potentially inform future policy considerations to mitigate such events in the future. Second, we sought to develop a model that could be used by policymakers and researchers, and currently is being used by such academics to further assess the economic impact of the blockade, and apply this methodology to study other hypothetical blockades, which you'll see we have done in the study. Lastly, this paper sought to measure other risks to Qatar's trade network through something called the Herfinda Index, all of which I'll explain shortly. The methodology we followed is twofold, which includes both an empirical study and a theoretical study. We do this so that we ensure the robustness of our results. Empirically, we calculate and feed data into our multi-sector, multi-region applied general equilibrium model, which is a very common model used in international trade, to evaluate the impact of the blockade on Qatar's economy. Whereas theoretically, we calculate areas of risk across Qatar's trade network in terms of trading partners and perhaps a concentration of products within certain trade partners. For our empirical approach, we tailored the multi-country, multi-sector applied general equilibrium model, which is a Ricardian equilibrium model, which has been used as a primary tool, as I mentioned before, for policymakers and researchers to study the impact of trade policy reform. In our model, there are 4 key functions that contributed to the setup. On the slide, you'll see 2. We'll begin by looking at the utility function, and I'll quickly brief over the calculus so that we can discuss the results. This may be a little too sophisticated and usually is just placed behind the model in a paper. When looking at the utility function, the key takeaway here is that consumers prefer a variety of goods, which means that countries have a different preference for imports from Qatar. In this function, we're looking at the preferences of consumers in country I for output from sector M to be consumed in country J. If we look at this scenario on the bottom page, that will help orient the audience. Now, because the country expenditure for each sector is fixed and the output of each sector is different, we'll also be looking at a budget constraint below. When looking at the budget constraint, this is defined by the product of the price and consumption of sector M output produced in country I and consumed in country J. That's equivalent to the wages multiplied by the labor of country I and the aggregate trade deficit of country J. These equations will inform what we're going to discuss in the next couple slides. Looking at our third function, our production function, this is a function of the productivity of country J, the consuming country, in producing 1 unit of output of sector M output, and the iceberg costs associated with delivering one unit of sector M output in country I. Now, iceberg costs are the costs associated with transporting 1 unit of output that decreases linearly with the distance required to cover. Finally, as all economic models must be solved, if we look to our fourth equation, this helps us solve, this is a condition that we need to clear to solve our model in equilibrium, essentially, where functions are maximized so that we may feed data into the model to determine the factors endogenously. To solve equilibrium for this economy, prices, wages, consumption, labor, and output allocations are represented by the goods market clearing and the labor market clearing, with the conditions typically applied to all economic models, where consumers maximize their utility constraints subject to their budget constraints that we saw in the previous slide, and firms maximize profits while markets clear. At this point, now that our model is set up, we then proceeded to calibrate the data to feed into the model for some interesting results. We'll now proceed on to the data calibration part of this study. Once the models and its parameters were set up, we calibrated the data following the procedure laid out in a paper Kehoe and Kehoe from 2014, using data from 2 data sets. International trade flows were leveraged from the UN Comtrade database, in addition to data on domestic production from Instat, which provides information on gross output for manufacturing industries. We merged the 2 data sets and cleaned an aggregate trade flows to estimate domestic expenditure shares by subtracting net exports from gross output of each industry. Now, in this situation, it can be expected that domestic expenditure could equal 0 or be less than 0. In these situations, we assume the domestic expenditure for the industry is equal to the average domestic expenditure of that country. If we focus our attention to the right side of the slide, I'll do the same, and I will briefly discuss, briefly identify the highlights of the calculus here, just to focus on the key takeaways. When solving the model, we normalize iceberg costs, wages, and productivities to equal 1 prior to the blockade, because we're just interested in the impacts post-blockade. We can then ignore the calculus for now, and in summary, we are then left with exogenous variables to calibrate and derive from the data, which include trade deficits, labor supply, expenditure shares, and taste shifters, represented by functions 2a, 2b, 2c, and d, respectively. If we look at 2a, this function solves for trade deficits, and all of this information can be derived from our data, but this is just so that we can explain our model in the paper. Function 2b then solves for labor supplies. Similarly, function 2c solves for expenditure shares, and lastly, function 2d solves for taste shifters. Once we calibrate our data and put it through the model, we're able to then simulate the blockade in the model. To do so, we increase iceberg costs between Qatar and the blockading countries so high that trade falls down to 0. If we look to table 1, we see that the export and import shares before and after the blockade. We see that Qatar does not trade very much overall with the blockading countries. I believe if we take a look at this amounts to around 6%, a majority of which was being traded with the UAE and mostly focused on imports and not exports. This is an important point that we'll be able to appreciate in the coming slides. So the key takeaway is that not much was being traded with the blockading countries, and a majority of the trade was focused on imports. Now that we have the before and after import and export shares, we can then look into the change in imports and exports following the blockade on the right side, which provides more context into our results. We look at figure 1, we see that the exports from Qatar in blue decreased for almost all countries following the blockade, and that imports from non-blockading countries will increase significantly. So here we see that we're looking at the UAE, Bahrain, Egypt, and Saudi Arabia. And these have just gone down because of our model, and we've held constant for that. Overall, we see that domestic production increases by roughly 5%. If we consider the fact that over 50% of consumption comes from domestic production, we can appreciate the fact that an overall increase of just 5% in domestic production is quite significant. Overall, this simulation exercise tells us that the impact of the blockade was minimal as compared to hypothetical blockades from either countries such as the US or Japan, on whom Qatar is heavily reliant on. So if we just take a moment to look at the table, look at figure 1 once more. Those with stars at the top highlight the amount of how much Qatar would import, how reliant essentially Qatar is on these countries. And we see that a blockade with either the United States or perhaps Japan would have a significant impact. We also examine the change in Qatar's imports and exports by industry, just to pinpoint where a majority of these changes are taking place and what the industry level impact was post-blockade. Table 2 provides us with the industry codes, which serve as a reference to Table 3. The main takeaway here is that the largest industries being impacted are agriculture and mining. Mining, of course, makes sense. Agriculture then serves as the main supply of food, which also makes sense. In Table 3, we see that each industry's share of total production before and after the blockade, and we also see the percentage change in the production following the blockade. As we can see, these two sectors are the largest. In both sectors, domestic production increased, but because our data set does not account for policy responses following the blockade by nature of the data, for example, sourcing food from alternative trade routes, the growth in the agriculture industry, we believe, has been understated. However, I think if we have the time and if our post-project plans proceed as expected, we can acquire data from 2020 and run the similar exercise to get more accurate results to see how the agriculture industry had also changed. To examine the impact of the blockade on Qatar's welfare and looking at the economic impact of Qatar's welfare on Qatar's economy, we manipulate the utility function, but I'll spare you the calculus there. We've already taken a look at the utility function for now. If we look at figure 2, telling us about the change in Qatar's welfare and GDP compared to other hypothetical blockades. We see that welfare had fallen in Qatar by 0.65%, which is not such a large change, and GDP had decreased by 2.66% following the blockade. We also see that hypothetical blockades, as mentioned before, with countries such as the United States and Japan would have had significant impacts on Qatar's welfare and GDP due to the fact that Qatar is heavily reliant on imports from both these countries. That brings us to the end of our empirical analysis. Our empirical analysis and our model allows us to factor in changes in trade behavior. However, to ensure the robustness of our results, we went ahead and conducted a theoretical analysis using the Herfindahl index to confirm where the risks in Qatar's trade networks would lie. In addition to our model, we then evaluated Qatar's trade network using the Herfindahl index, which is defined as a measure of risk based off of variance. Typically, a higher Herfindahl means higher risk. So if we pay attention to figure 3 on the left, we see that the Herfindahl index for each country showing concentration of exports and imports. We see that Qatar's exports are highly concentrated across countries such as Australia here, Oman, and the UAE. However, when we're looking at the imports in red, we see that there's a fairly even distribution. That's a good sign. That means that Qatar has its imports fairly diversified, and so a blockade from either one of these trading partners would not pose a significant risk. However, when we're looking at the blue bar charts bars here, these are the exports, and we see significant concentration among some of these countries. So The Herfindahl identifies Australia, Oman, and the UAE as posing significant risk. Another analysis we did using the Herfindahl in figure 4 was for each country showing concentration of exports and imports, but this time among products, not just among trading partners. We see that Qatar's exports are concentrated among Australia, Oman, and Saudi Arabia, although imports not so much, which again is a great sign and confirms our findings from our empirical analysis. Overall, this tells us that shocks that affect Qatar's exports will have a greater impact on the economy, as opposed to shocks on Qatar's imports. Overall, our results suggest that the blockade had a minimal impact on Qatar's economy, and this is what you witnessed over the years. And the trade network is relatively resilient. We arrived at 2 key findings. First, through our model, we find that the blockade had a minimal impact on Qatar's economy, mostly because Qatar does not trade much with the blockading countries, as we saw. This amounted to around 6%. However, its exports among products are concentrated with the UAE, meaning that a majority, whatever hit Qatar took, lied there, although little. Second, the Herfindahl index tells us that Qatar's trading network is well diversified across trading partners, although exports may be slightly concentrated. In sum, Qatar is not likely to experience a significant impact of shocks to its imports, but will experience significant shocks to its exports. Therefore, we have policy implications going forward. Overall, the recommendation is to diversify our exports and how we can do that. But that's for another study. Looking at the study, and whenever we're working with an economic model, there's never a perfect model, and there are several assumptions. In addition to that, data has several limitations, which we saw in this case. So the limitations to our analysis are that the data set does not account for trade routes and how easy it is for Qatar to source products from alternative locations, or even how important a certain product is to the country. Second, unfortunately, a drawback to our empirical approach is leveraged to identify which products Qatar is heavily reliant on does not factor in the ease with which these products can be sourced. For example, when we're sourcing milk from Saudi Arabia versus Turkey, there are significant considerations in both routes. At the time of the study, the data did not reflect changes in trade routes, and often this is because there is a gap in the data and crises, which resulted in potentially overstating the risk that Qatar faces, although we saw that it was still minimal, and we cannot source certain products from trading partners. When relying on data in such analyses, potential behavioral responses to situations are also not captured. These overall are the key limitations to our study. However, I believe if we're able to continue with our next plans and obtain data from 2020, these are concerns that we can address. During this research study, we learned that evaluating the impact of economic shocks is certainly complicated. Working with any economic model is also complicated, but also multifaceted in nature. We learned that there's a continued need for Qatar to diversify among trading partners and products. We also learned that such models provide a good comparison to study the blockade, as we studied hypothetical blockades in the model for them to provide as reference. So we'd definitely continue studying other blockades and simulate the model using updated data. Lastly, we confirmed that the blockade had minimal impact on the economy overall. In terms of potential post-project plans, we plan to secure data from 2020 to feed into our model and study how close our predictions came to the actual changes that took place in Qatar's trade network with this updated data. This evaluation will help us not only better understand the strengths and weaknesses of our modeling approach, but also potentially identify areas for more tangible policy recommendations for the economy. Before we open up for questions, I would like to highlight that this research study was made possible by a combined effort. I had another student researcher working alongside me, Halak Shet, and this effort was led by Professor Jack Rosbach whose guidance and courses equip students with the ability to clean and analyze large economic data sets, which as students at Georgetown, we are accustomed to do. However, these data sets were much larger than we were used to. This was done on software such as R, Stata, and Excel, which we had received guidance from. The study didn't only allow us to clean larger data sets, such as the Comtrade and Instat data sets they received, but also really gave us the opportunity to apply what we had learned in the classroom. The study provided students like myself and Halak to truly experience the challenge of contributing to existing literature, which oftentimes is not as easy as it seems, to truly give credit to those who have produced literature and build on that literature. Also, experiencing the research culture firsthand and becoming immersed in an area of study that could potentially be extrapolated to study interdisciplinary events and contribute to other research with policy implications is unique. So there's definitely a lot we've taken away, and there's certainly plenty of research we can continue to do. But that brings me to an end to my presentation. Thank you, everyone.
Thank you, Alicia, for the informative presentation. Next up, I invite a team from Qatar University to present the research on...
Before moving on, if Dr. Michael would like to open for questions and answers.
I was just going to weigh in there. Are there any questions from the judges for our speaker today?
Yes, I can start. Okay.
Let's begin with Dr. Dana. Okay.
Thank you very much, Dr. Benedict. So it's a very, very nice presentation, very relevant actually, obviously. So I just have 2 to 3 questions. So my first question, in one of the slides, you compared the welfare and the GDP. So how do you define welfare in the context or in the model you use, or how do the model you've used defined welfare? So that's my first question. You are muted.
Sorry, Dr. Dana, I think that's a really, really good question. When we're looking at data, I'm not entirely sure how welfare was defined. There are certainly different ways welfare is defined, but overall, I'm assuming it's the quality of living that's contextualized in a data set. So this was based off the data that we had purchased, and we leveraged it just as is. That's a very good point. I think moving forward, we can look into how welfare was defined and how that impacts our results.
That's nice. And is the work been published, or do you have plans of publications? Because it's an interesting work, and I think when you polish it and publish it, maybe you would look at the different definitions of the models you've used.
Absolutely. The reason we haven't published it yet is because there's still work to do. At the time of the study, the latest data set we were able to get was from 2002 to 2015. And because that was a few years ahead of the blockade, I don't think it truly captured the essence and the changes that took place in the trade routes. What we're planning to do is to purchase data from 2020, put that data through the model and see how our findings change. I think then the findings and our model will be more relevant, and we can proceed to publish the paper. This is something we've discussed with Professor Rosbach.
Just one last, I have one last question. Oh, that's fine. I'm okay. Sorry, it's just interesting work. Just one more last question. You said the highest export is Oman according to your model and the data. I just want to know what kind of products are exported. Is it related to oil and gas or?
Sure. So we're looking at products. So if we look at, I'm just going to go ahead and share my screen real quick so that I can refer. See, so all the industries that you're looking at on the left-hand side, let's go to the right slide. These are the industries we looked at. So there's certain industries according to the World Bank that were coded. And because they were coded, we were able to also pull that from the data. There are certain limitations. There are some industries that are not covered, but we were able to do our best to match the ISAC codes to the codes that were in the data. So these are the industries, to answer your question, that were covered in imports and exports. Now, if you're asking me specifically what products were being traded majority in Oman, unfortunately, we haven't. This is one of the limitations to our study. We haven't been able to identify what certain products were amounting to that were amounting to that export share with Qatar. But that is something interesting. Unfortunately, it's just the limitations of the data, and with this analysis, we sort of have to redefine our boundaries according to what we have. But I agree with you. I think that would be very interesting.
Okay. Dr. Nader, I know you had a couple questions.
Yes, thank you so much. I see other hands, so I'll be quick. Thank you so much, Isha, for your really excellent presentation and incredible research. Just a quick question about the model. I think you showed that the applied general equilibrium modeling can actually be quite useful in this context. Two questions. What changes would you have to make to this model when you start looking at changes in trade routes, changes in taking into account re-exports from countries that Qatar imports from, and other factors that you want to incorporate? And the second one is related. The second question is, did you look at other kinds of empirical models that you could use before you settled on the applied general equilibrium framework? Thank you.
Thank you. So your first question is a great question. What would we change if we were to incorporate new data and move away from some of our assumptions? I think the main thing we would change at the moment is our homothetic preferences, our assumption of homothetic preferences, meaning that consumers and countries do not differentiate between the types of substitutes to products that they currently have, which in reality does not hold true. But because this would have overcomplicated the model, and I think that it wouldn't have worked with the data we had assumed that consumers and countries have homothetic preferences, meaning that there's just a homogeneous preference for different substitutes. There's no favor. I think that would have drastically changed the model. And I'm interested to see if that's something we can actually incorporate in the model or not. If not, it would be good to at least dedicate a portion of the paper to a literature review on that area. In terms of other empirical models, there are several empirical models when we're looking into international trade, but I think this is the one model that's used throughout international trade analysis or policy analysis, where you're looking at when you're studying anything along the lines of trade embargoes or trade bans. And I think just by nature, the nature of the blockade just fell within this bucket. I don't think there would have been another model we would have used, but I mean, there's a possibility in that. When discussing with a professor or expanding our breadth of research, that is definitely a possibility.
Thank you. Last question in the interest of time, Dr. Khalid, I know you had your hand up. You're muted though.
Can you hear me okay?
Yes.
Yeah. So thanks, Alicia, for the presentation. I have a couple of questions actually. Dr. Dina referred to the different sectors in which trade was conducted. I wonder whether there's an opportunity for the model to weigh the different sectors differently based on not only utility but actually like importance to the country. For example, trading miscellaneous goods is not as important as, for example, trading milk or egg, pharmaceutical stuff. And so maybe there's an opportunity to talk to key opinion leaders in the country to think about what was very important during that time, and then have a different weightage. Would your model accommodate that? That's a really important point, and that's something we'd like to discuss. That's mentioned in our
potential project plans. I think the model at the moment does not have the capability to give certain products or certain industries preference. That's just a limitation of our data. But your point to weighting certain industries over others, I think that would be possible. One of the ways to do that moving forward without having to speak to policy leaders is to look at how Qatar responded to the blockade in terms of which products it was sourcing from which trade routes. Once we do that, we can then acquire a new data set, confirm that, and add in a weightage to the industries. I think that's something we can do using the Herfindahl index.
Okay, thanks. The other comment I was going to make is that I think your conclusion is a little grandiose in saying that the blockade had no economic impact, and the economic impact extends way beyond trade, right? There's foreign direct investment, there's reputational damage, there's all sorts of like proxy things that happen outside of just trade. So while your data probably demonstrates that there was limited impact on trade, I think generalizing to economic impact in general is probably a very simplistic conclusion. So that's just something to watch out for if you go to peer review on this.
No, absolutely agreed. You're right. This is overgeneralized. I stand corrected, and let me just clarify. So in this paper, when we're talking about economic impact, we're just referring to GDP price held constant. There's a tendency to oversimplify when we refer to the economy and economics. We tend to just focus on GDP. You're right, oversimplified. But in this context, when I say economic impact, just talking about GDP, the impact was a decline in 2.66%, which I think you could say is a safe margin. Qatar did recover decently. And then when we're looking into welfare, so the overall welfare of living, there was a slight decrease of 0.6% in our model, which again is not too much of a hit. So overall, our conclusion would be that there's a limited impact there's a limited hit that Qatar took, but it was able to recover, which will be able to support, I think, with a more updated data set. But completely agree with you on the oversimplification point.
Thanks.
Yeah, Dr. Mohammed, can you make it quick? I think we're running out of time.
Well, this is the last question. No, thank you. Thank you for a good presentation. And I agree with you that Qatar needs to continue the diversification. My question, what's your suggestion or vision for continuous diversification?
Based on the data and based on our findings, in terms of continued diversification, is for Qatar to continue doing what they were doing. Post-blockade, we see that certain countries came to work with Qatar, including Turkey, Iran, Pakistan, and India. These are alternate trade routes that Qatar can benefit from in the long term. Not only that, but we also see that Qatar increased its own domestic production. That's another way to mitigate such shocks to imports and exports, and Qatar was able to respond fast. Now, there's another part to this beyond diversifying trade partners. It's looking inwards and identifying which sectors we should work on to diversify, and identify which sectors we're heavily reliant on other countries. And I think that's a separate analysis, but that's just a summary of what my opinion is.
Thank you. Thank you.
Great. Thank you very much. And thank you, Alicia, for a great presentation.
Thank you.
Yes. Thank you, Alicia. Thank you so much. Next up, we have a team from Qatar University to present the research on design and development of rapid electric vehicle battery charging system for community use. Again, like your colleague, please share your slides to begin. Anas?
Sorry, I was
unmute yourself. Yeah, we can hear you now.
Okay. Can others see the slides? I'm unable to see the slides.
Can you see the slides?
Yes.
Yeah.
Anas, can you please put your camera on as well?
My camera is on.
I have a big green screen that's flashing.
So I
reshare, Anas.
You're unable to see the slides?
Yes, I'm unable to see the slides. I just have a big green box flashing. I can see his camera, but nothing else. I saw the previous slides fine.
So what about
there we go. That's fine now. Okay.
You can see now, yeah? Okay,
yes.
Perfect.
Okay.
You can Anas, yeah.
Okay, so hello everyone. So our project is design and development of rapid electric vehicle battery charging system for community use. The student's name, undergraduate, and our research mentor is Professor Iqbal. So one of the major concerns in this world is the greenhouse gases emissions, which one of the biggest contributors to that is the transport sector. So one of the solutions that is presented by most of the companies in the world is switching from internal combustion engines to electric vehicles. So to do that, there are some specifications that consumers are used to, which the EVs couldn't override that. One of the main limitations is the long charging periods. So the main objective of this project is to build a rapid charging station for EVs. So to start with, our procedure was to start with an extensive literature review. This literature review enabled us to specify the main components of the system. So we did a comparison between the batteries, and we chose one model, which is the Tesla Model S. And then we specified the DC-DC charging converter, which is a synchronous buck converter. And then we also specified the filter type for the power source, which is an LCL filter. And then we did the AC-DC rectifier controller, which was 3-phase controller. So we choose the DQ0 method controller, which is switched from 3-phase to 2-phase and control based on that. And then we specified also the controller for the PV panels. So we use MPPT controller. And then lastly, for the charging of the battery, we used the CCCV method, which is constant current and constant voltage method. So after specifying all these main block diagrams, we calculate the components of the specified models. And then we used MATLAB Simulink to simulate it. And then we implemented the hardware charging system. So for the open loop block diagram, we can see we have two sources. We have the solar panels, and we have also the grid. So from the grid, we go into the filter. From the filter, we go to the AC to DC rectifier. So we have here a DC bus, which is also from the PV panels. Usually a very small voltage is generated by the PV panels, so it needs boost converter. So we have one bus here, and then from this bus, we can go to the buck converter to find the optimal charging voltage for the battery. In the CCCV charging mode, so at the CC, which is the constant current mode, we can see that the current should be constant always at this mode, and the voltage is increasing. And when we switch to the CV mode, the current should be decaying exponentially, and the voltage is constant. So this is the state of charge of the battery. So in the CC mode, it should linearly increase, and then at the CV mode, exponentially increase slowly. So we start with designing the buck converter. So to design the buck converter, we need to know two basics, that there is a T on and T off. So T on is basically we look at the MOSFET when this is open circuit or closed circuit. So when the switch is on, we have a short circuit here and open circuit at the diode. So we get the mode 1, which is T on. And when the MOSFET is off, we get a short circuit here and we get a circuit here. So we get these waveforms. So we can see at the mode 1, which is T on, we have an input current because this is a short, but when it's T off, it's an open circuit, so there is no current anymore in the N. But we only have an output current always because we have a short circuit here. And this is the waveforms. So also, if you see at the capacitor and the inductor, there's always ripples because there is a filtering here and filtering here to reduce the ripples. So we need to choose that values accordingly. So to choose the inductor voltage, so we have a volt-sec balance rule, which is we want at the T on, the voltage is equal at the T off also. So this is the voltage second balance of inductor. So according to this rule, we can then find the ripple of the inductor, and from the ripple of the inductor, we can find Imax, which is the highest value of the current of the inductor current, and the Imin is the lowest value of the inductor. And to find the minimum inductance value for a continuous transmission, we should put Imin equals 0, and then we can have a minimum inductance value. From this minimum inductance value, we need to choose a higher value than this one. So this is the minimum inductance value. So for the capacitor, we do also the current sec balance rule, which is exactly the same, which is the current going inside the capacitor is equal to the current going inside the capacitor at the T on and T off. So through here, we can find the voltage ripple and find the minimum capacitance. Okay, yeah, here. So after choosing the inductor and the MOSFETs, we need also to choose after the capacitor and the inductance, we need to select the MOSFETs, which is the switches. These are very critical in selection because there are too much current going through it, and also the high frequency that will be implemented. So we needed to find the average value of the pulse current because we are having a T on and T off. So we need to find the average value of that. And then we also have, there is a minimum on-state resistance. This is in the datasheet of the MOSFET. And then based on that, we can select appropriate frequency switching based on the turn-off delay and turn-on delay. So when they are switching, there is always a very small delays in the implementation. So that's for the MOSFET. For the diode, we only look at the current, the average value of the current, and we need a faster reverse recovery characteristics with a little bit of delays. So for the filter design, so we choose an LCL filter, not an L filter, because L filter usually comes with a very high values, which is bulky and have a higher attenuation of harmonics. So designing an LCL filter is quite complicated. It's an iterative procedure. So basically there are 4 conditions to be achieved. The filter capacitor should be less than 5% of the base capacitance, and the total value of inductor is less than 10%. We are having 2 inductors, and we are having a passive damping required, and the F resonance should be between the F switching, which is the switching, and the F line, which is the 50 Hz of Qatar. Okay, so we did some assumptions at the beginning because we are having we need to find the input power. So we assume that there is a 95% efficiency at the DC-DC buck converter and 95% efficiency at the AC to DC rectifier. And then we know that the battery output that we need to the module S battery that we selected from its datasheet, we can find that it's 120 kilowatt. So from here we can see that we need 132 kilowatt. So we did the calculations and then verified the 4 conditions, and we achieved the 4 conditions perfectly. So this is the full simulation without the PP panels. This is only from the grid at the 3-phase source, and then we have an LCL filter here, and then from here AC to DC rectifier, and the AC to DC rectifier is controlled through DQ method, and then we have a synchronous buck converter here. And this is the CCCV charging controller. So for the results, for the simulation results, we can see that the rectifier voltage output, this is the only rectifier after the AC to DC rectifier. We can see that there is a very high voltage. At the beginning, there was some pulses overshooting until the control system achieved the DQ control method, achieved the 1000 voltage. Also, we can see that the power factor was a little bit distorted at the beginning, but it's a very small amount of time. And then you can see the voltage and the current, the input voltage and the input current is in phase with almost power factor of 1. So for here, we can see that through this, the battery SOC was increasing linearly, and the current was constant. This through the CC mode, and the battery voltage was increasing softly. So from here, from this figures, we can estimate the charging times through the gradient of the SOC. So since the CC mode is only open to 80%, so we estimate it to 80%. So we get from the gradient, we have 0.038% per second, and then we can just estimate from here to 30.7 minutes. For the CV mode, we can see the rectifier output voltage also rectified, and then we can see the SOC is also increasing exponentially, but the current is decaying exponentially and the voltage is constant. So this is the CV mode, which is from 80% to 100%. So after we get the simulation results, we compare it with the Tesla S85 battery, which is the model that we chose. So their indications at the charging of on their data sheets, it was 38 minutes, and ours was 30.7 minutes. It was also 10 to 80%. So, and with all the same battery specifications. So we also added the solar panel system. So we have the solar panels here, and then there is a boost converter because the small voltage that generated at the solar panels. And we have the MPPT controller. We have the synchronous, the same design synchronous DC-DC buck converter because the same power is coming from here. And then we have the CCCV charging controller. So here we can see the output power from the MPPT from the solar panels. So this is 12 times 10 to the power 4, which is almost 120 kilowatt. So we also did it for different temperatures because the temperature affect the generation power of the solar panels. So you can see when the highest temperature, it generates a little less than the desired amount. So this can be helped with the grid. So for the hardware implementation, we used FPGA, voltage sensor, current sensor, which are Taras technologies, and also the grid drivers, battery, and ADC and power converters. So we had to scale down in the lab, so we didn't use, of course, the same amount of current, which is power, which was 120 kilowatt. This was we had some limitations at the lab that we'll discuss later. So the input voltage is 400 volt and the output voltage is only 100 volt, and we scaled down accordingly to that. So for the boost converter open loop results, so this is open loop without the control. So we can see that the input voltage here is 20 volt per division, so it's almost 20 volt, yeah. So the output voltage here is so it's 100 volt per divisions. It's a little bit than the division, so this is 80 volt. So we can see that it's increased from 20 volt to 80 volt. And you can see here that when we are, so this is the input output voltage and current at 75% duty ratio. So at B, we experiment the dynamic behavior. So we change the input voltage and we see what happens to the output. So here, the input voltage is here. So we increase the input voltage. You can see the output voltage is also increasing because this is open loop. So also the input current is increasing. It requires more power and so on. So that's the main idea of open loop, but we don't want that. We want a closed loop. So for the closed loop results, so you can see here in the dynamic behavior, we have an input voltage here. So we increase the input voltage, but the output current and the output voltage, there was no change in that. So that was the main aim of the controller. And of course, and in this one, we changed. Yeah, in this one we changed the load. So we changed the value of the resistance because this was only experimenting on a resistance load before implementing the battery to ensure the safety. So we changed the input current. So you can see the input voltage also decreased, but the output voltage stayed always the same. The output current decreased, but the output voltage is the same, which is the main theme. The output current is decreased because we changed the resistance. So the battery charging final results. So in the CC mode, we can see the output current was constant, and the voltage is increasing. And for the CV mode, we can see that the current is decaying and the voltage is constant. So this was while restructuring the results. So final discussion. The optimum fast charging was achieved, which is also was almost the same time as Tesla, but they had better efficiency. The charger is designed that from 10% CC and 80 to 100 CV. The solar PV is used only in the simulation. We didn't implement it to the implementation because we had some limitations of availability of solar panels and the maximum current, and we had hardware battery models that's different than Model S and so on. So the conclusion of that, we have designed and controlled different EV charging methods and compared it in terms of charging times. And then we choose the CCCV method. And the PV system gave good support in the simulation with the given power. For the future work, we could implement a higher power rating in the lab and so on. And wide band gap devices can be used for the fabrication of the power converters. This is highly needed in the implementation. And there was an extension of the project to convert it to home charging station using V2G technologies and vehicle to home technologies. So one of the future works also is to implement a mobile application that shows the charging stations nearby and also show the state of charge. So the final outcomes, we had for our SDP, we had won the 3rd position in the SDP, and we have published 2 conference papers and 2 journal papers. And thanks for UREP for granting this opportunity for us. And if you have any questions.
Question. Yes, Dr. Mohammed, go ahead.
Thank you so much. Thank you for a good presentation. I have only one question. This is for economy side. Is this techniques will increase the cost of electric vehicle? If yes, what's the percentage?
Is there an increase in what, sorry?
The cost of the electrical vehicles. This is for economy side.
Yes, but we didn't study that because we were studying it from charging perspective, not inside the EVs. But in the charging perspective, of course, there is always an increase because there's always a trade-off. So if you want to increase something, there is a trade-off between that and that. So if you want to, for example, get a smaller component with higher achievement or higher specifications, you always need to pay more.
Do you have any percentage, 10%, 20%, or you haven't any idea about that?
I don't think that we did that. I think my friend did it and we showed it in the report, I guess. But I'm not sure. I think in the paper that we published in the journal, this paper, I think that we showed that, but I don't remember it now.
Thank you. Thank you.
I have a question for you. Is there any impact on the longevity of the battery life with using these different charging regimes? Because that could have a very significant impact in long-term cost.
You mean impact on the battery itself or on the cost?
Yes, on the batteries themselves.
On the battery, yes, of course, because in the CC mode, we pump very high current, which leads to increasing temperature in the battery. So that's why we stop at 80%. So we switched then to the CV mode. At 80%, this is one of the safest procedure that goes. So we can't exceed at 80% with the CC mode for the concern that you are saying. So the CC mode is very fast charging, but also it affects the battery because it's a very high current. So we need to stop at 80%. This is to increase the lifespan of the battery.
Okay. Dr. Dana.
Thank you. Thank you for a very nice presentation. So I just have a question from the framework methodology perspective. So there was one slide where you showed the literature review, and you kept saying we've chosen this, we've chosen. My basic question here, on what basis you make these choices?
So okay. So for example, in the battery model, so we studied like 8 or 10 different batteries, and we saw the rating of each battery. And from here, we can see also the charges available for that battery. And from there, we can choose which battery that needs to have a better charger. So can achieve a better charging at that status. And for these ones, so we compare, for example, the DC-DC converter. Also, we studied different converters. So we did the whole paper that published that we studied around 6 or 7 different converters, and we choose this influence buck converter.
So you have a criteria for each one. That's what you're trying to say.
Yes, but not criteria. It really depends on which one. So, for example, what is needed for the charging system, and if both is needed, so we then have a criteria of selection.
Okay, that's good. Thank you.
Thank you.
Dr. Nader?
Yes, thank you, Anas, for a really rich presentation. I'd like to follow up on Dr. Michael's question regarding the question that Dr. Michael asked about battery life, but how about, you might have already mentioned this and I didn't catch it, sorry, this is not my field, but how about energy consumption? To what extent is this procedure also, let's say, not as efficient? And also, I guess, relates to economic costs as well, but how I mean, it's quick, but to what extent does it have other implications in terms of energy usage? It also relates to battery life. It also relates to costs that was asked previously with Dr. Muhammad. Thank you.
I really think, thank you for the question. I really think that all of these questions are answered according to the battery type. This is not our design or our work. So it depends on the battery that we are using. So they invent a better battery, the energy will be better, the consumption, the battery span, it all will be better. And also in the datasheet, we can see the optimal charging rating for that. So it really depends on the battery. So,
can I just follow up on that? So with a given battery, do different charging regimes have different implications in the energy use? So if you keep the battery constant, what's the change?
Sorry, I didn't catch that. Can you please repeat it?
So you just rightly said that with different batteries, you're going to have a very different outcome. So for a given battery, just pick any one battery, the Tesla S, are different charging regimes all going to have a similar energy efficiency, or is it going to be different and therefore different costs?
Different energy efficiency. Yeah, of course it will have a different energy efficiency. It has to be the components that we designed. It has the same efficiency. So, for example, that we have a 90%, 10% losses in the DC-DC buck converter, for example, we'll have the same. But then there will be another losses in the internal resistance of the battery. This totally depends on the battery. Right?
All right. Any last questions from the judges? Seeing none, thank you very much.
Thank you, Anas, for an informative presentation. Moving on, we have a team from Texas A&M University at Qatar, who will explore their study on the influence of nanoparticles in the filtrate characteristics and filtrate cake formation of water-based drilling fluid. Arreem Dosari, can you please? Yes, perfect. Can you all see the slides?
Yes.
Dream your camera, please.
I'm sorry, the camera is off. It's not working.
Okay, please go ahead.
Okay, good morning, everyone. This is Arreem Dosari, a former student at Texas A&M University class of 2019 and a current reservoir engineer at Qatar. And today I'm here on behalf of my team to present our research that studies the effect of nanoparticles on filter cake characteristics. So if you look at this picture here, just let me remove this one. So here you can see a schematic of the well bore while the well is being drilled. And if you follow the arrows, you can see that this is the drilling fluid being pumped through the drill string and coming out via the drill bit and goes all the way to the surface via the annulus. So this drilling fluid is identified as the drilling mud, and it is there to serve important functions such as remove the rock cuttings, lubricate the drill bit, create overbalance conditions. And what we mean by that is basically when the formation pressure is being exerted on the wellbore, we counterbalance it by the mud pressure. And the mud pressure is slightly higher than the formation pressure to ensure wellbore stability. Moving on to the most important feature of the drilling fluid is the impermeable seal created by the mud cake, as demonstrated in here. So here you can see the drill string. And if you take a closer look, you can see the mud filtrate, mud cake is being formed here. And this mud cake is acting as a plaster on the formation. However, due to the mud pressure in here, some of the fluid are being leaked into the formation, and those are identified as mud filtrate or fluid loss. This kind of fluid penetrates the formation to a certain extent, and we call this area of penetration the invasion zone. The problem with this penetrating fluid is that it causes a problem while drilling, and therefore leading us to the motivation of this work. So from the industrial application side, while drilling, we lower logging tools to send records to the surface. But the limitation is that these tools have their own depth of investigation, and usually those depths fall within the invasion zone. So eventually the log data are heavily affected by the mud filtrate. And our goal is to use nanoparticles to improve the mud properties, in which it can reduce the filtrate volume and therefore get accurate log data and reduce operational problems. Now, from the academic perspective, we're trying to fill a knowledge gap as there are no studies reported on the correlation between the formation porosity and the nanoparticles morphology. Now, for the methodology, basically we started by preparing the base mud. And as you can see, we mixed all these components in the mud mixer and we kept it aside. And then we moved on to create the nanomud. So here we use two different types of nanoparticles. One is carbon nanotube and the other is silicon dioxide. The two particles have different type of morphologies. One is cylindrical and the other is spherical. Each particle was mixed separately with the base mud to form the nanomud. And we mixed each particles with a certain concentration of 1 and 2 weight %. So eventually we had 4 nanomud samples. All the samples were ultrasonicated, and we noticed that during the sonication process, the probe generates some heat and therefore some water could evaporate. Therefore, we kept it in a cold bath. And this is a picture of the ultrasonication process within the laboratory. Next is the API fluid loss test. So API stands for American Petroleum Institute, in which they came up with a test that mimics the reservoir conditions. If you recall the schematic in here, it's basically the testing apparatus is mimicking the exact conditions. So here we have the mud sample at this temperature, and here we have a porous ceramic disc. So we use two discs, one of a pore size of 5 microns and the other of 10 microns. And basically, this resembles the formation. And we tried to apply the mud pressure via piston in here. And then we have a back pressure. I'm sorry about the screen. It seems that I cannot move it. So basically, this is the back pressure of the formation, where we're going to have the mud cake being formed on top of the ceramic disc, and the filtrate will accumulate in this chamber. Finally, the filtrate sample will be collected at this point. Now, this is for the sake of explanation, but the testing apparatus is set to be vertical. And here is the actual testing apparatus in the lab, where we monitored the pressure and temperature from these two gauges, and everything was happening inside. And here we can see that we have a glass wall for safety purposes. Now to the results section for the CNT nanomud filtrate. I'm going to start with the 5 micron ceramic disc. So here you can see the y-axis resembles the filtrate volume collected, and x-axis is the collection time interval. Now for the color legends, we have black as the base mud, light blue base mud plus 1 weight % of CNT, dark blue is base mud plus 2 weight % of CNT. So just to mention before I start, the sample collected at half a minute is called the sprit and it's the least reliable. And the sample collected at 30 minutes is called the whole filtrate, and it is the most reliable. Now we notice that the filtrate volume is increasing nonlinearly with time, and the filtrate volume collected for the nanomud is lower than the base mud. And we can see a higher reduction in the filtrate volume was observed at CNT of 2 weight %. Now here is a picture of the mud cake being formed on the ceramic disc. Next, we have the same kind of plot for the 10 micron ceramic disc. Again, same legends, same axes. So the filtrate, the volume of the base mud filtrate at 10 microns is higher than the base mud of at 5 micron per disc. So the conclusion is that higher disc porosity means higher filtrate volume. And at the end of the 30 minutes collection, the whole filtrate, we noticed that there is a clear reduction of the filtrate volume compared to the base mud. And here you can see the ceramic disc of 10 microns per size. And one thing we noticed also is that with the increase of nanoparticles concentration, the filter cake in here tend to be less coherent and less stable. It seems to be slurry, which is something not desirable. It's desirable. Now moving on to the silicon dioxide nanomud filtrate. Here we have 45 microns. So at the beginning, we have similar trend. The filtrate volume is increasing with time. And we noticed that at 1 weight %, it was a little bit higher than the base mud. However, after 15 minutes, the data trend has changed. And then at the end, eventually all the nanomuds were showing notable reduction compared to the base mud. Now for the 10 micron ceramic disc, again, same story, but the 1 and 2 weight % are behaving the same. And they are also having higher reduction in terms of the filtrate volume. But when we compare the mud cake of 2 weight % of silicon dioxide compared to the CNT, the silicon dioxide 2 weight % seems to be more stable than the 2 weight % of the CNT nanomud. Moving on to the reduction in filtrate. So basically here we have the results for the CNT nanomud, and here we have for the silicon dioxide. Here we have the percentage of change, and again here with the same legends, and we have the two categories of the two ceramic discs. So what we did is basically we compared the whole filtrate sample of each category with the base mud, and from there we calculated the percentage of reduction. We noticed that for the CNT, when we the reduction was the reduction more for the 10 microns per disc size than the 5 micron disc for the CNT, and their 2 weight % for the CNT nanomud has lower filtrate than the 2 weight % of the silicon dioxide nanomud. However, the mud cake was thicker for the CNT compared to the silicon dioxide nanomud. And in terms of comparison for 1 weight %, it seems that the silicon dioxide nanomud was better than the 1 weight % of the CNT nanomud. Now for the porosity, just to recall what are the desired filter cake characteristics, we want it to be impermeable, we want it to be thin, and we want it to be uniform. So if you look at this button here, we have the porosity, Again, here we have the same color legends, but we're adding the porosity of the ceramic disc. And here we have for the CNT and silicon dioxide. And basically what we did in here, we measured the porosity of the mud cake by evaluating the dry and their wet weights. And it turns out that the base mud cake was more porous at the 5 micron disk compared to the 10 micron disk, meaning larger pore disk. That means more porous filter cake. So for the CNT at the 2-weight%, it could not be measured. As I mentioned before, it was a slurry and less coherent and less stable, so therefore we could not measure it. However, we were able to measure the 2-weight% for the silicon dioxide nanomod. And it seems that the CNT nanomod makes more porous filter cake than the 1-weight% of the nanomod when we compare the 1-weight%. So eventually we concluded that higher concentration of nanoparticles equals lower porosity. Now, in terms of the thickness and uniformity, here you can see we have the mud cake thickness, and here we have the pore disk sizes. This is the silicon dioxide nanomod, and this is the CNT. Now, again, as I mentioned before, we could not measure the 2-weight% CNT, the darker blue, because it was less stable. So we noticed that the CNT 1-weight% had stable filter cake compared to the 2-weight%, and the silicon dioxide nanomod created larger filter cake than the 2-weight% compared to the 1-weight% of silicon dioxide. And the CNT nanomod filter cake appears to be more porous and less uniform than the silicon dioxide nanomod filter cake. And to check for the uniformity, we use a scanning electron microscope to take pictures of the nanomod surfaces. And by comparing to the base mud, it seems that the silicon dioxide nanomod seemed to be more uniform compared to the CNT nanomod. Now for the conclusion, in the study, the filtrate characteristics of the silicon dioxide nanomod and CNT were studied through 2 pore sizes of common formation porosities, and the fluid loss is reduced by adding the nanoparticles to the drilling mud. And it seems that the addition of nanoparticles reduced some of the porosities of the filter cake, and the higher concentration of CNT nanomud was had lower fluid loss compared to the silicon dioxide nanomod at 2-weight%. However, the filter cake thickness is larger, which is something not desirable. And based on the filter cake thickness formed, the lower the concentration of silicon dioxide seemed to be better than the CNT nanomod. So our conclusion is that the best candidate for particle and concentration for the drilling mud is silicon dioxide nanomod at 1-weight%, as it was able to achieve all the other criteria that we're looking for in the mud cake. Now for the significance and post-project plans, I just want to highlight that, in the drilling operation, it costs a lot to rent a drilling rig, in which it can cost 2.5 million per day. So any delay or any problem within the wellbore, even for a single day, it can cost a lot. And therefore, in this study, we try to prove that the addition of nanoparticles will result in significant reduction in fluid loss, and which by turn will result in less operational problems and more cost saving. As for the gain experience by the students, we were first of all introduced to the safety culture, where we entered high technology and advanced laboratory, and where we learned more safety procedures as opposed to what we learned in the normal labs. And also we were able to learn, work on a real problem in the industry and come with proactive solutions. Also, we were able to learn how to conduct an academic research, do report writings, and also present technical presentations. And finally, because we are a group of 6 students, we learned how to work together and manage our time and share the information between us to get this work going and complete the whole project. And finally, in terms of the outcomes of this research, Dr. Anu, who is our mentor, presented this work in the 5th Thermal and Fluid Engineering Conference. and also presented it at the third EAGE workshop. And right now we're in the process of preparing a write-up for a journal publication. And one important outcome of this project is that our mentor is are continuing on are planning for a continuation of this project, in which there is a discussion with one of the oil and gas companies in here in Qatar to implement a pilot test of one of the outcomes of this project. So even though that we are still in the process of publishing, papers, we still were able to get the eyes on the outcomes of this project, and therefore probably in the future execute it on a pilot phase in the field. And this is it. For the acknowledgement, we would like to thank UREP for the grant. Without it, this project wouldn't have been done. And we would like to have special thanks to Mr. Arnel Carvero and Mr. Romel Yark for their valuable support throughout this project. And this is the end of my presentation. If you have any question, I'll be happy to answer.
Thank you very much. Are there questions from the judges? Yes, Dr. Mohammed.
Thank you for the presentation. Good presentation. I'm asking about also the economy side. Now in the presentation and the proposal, the addition of nanoparticles to drilling mud, adding silicon dioxide, multi-walls carbon nanotubes. My question, could you give us more details about these materials in terms of easy to use and cost? And are they available in the local market or should be imported? And what is your evaluations between the economy, benefits, and technique? Thank you.
Okay, so in terms of the nanoparticles, they were imported. They were from a company called Sigma, if I'm not mistaken. And it just, if my memories is not failing me this time, I think for 500 grams, it cost about $600 for silicon dioxide. Now for the nanotube, I cannot recall the exact number, but yeah, the particles are important. And for the silicon dioxide, it's relatively cheap. However, we selected with the carbon nanotube as it has similar characteristics, and it will help us in terms of the comparison between the two nanomods. In terms of your last part of the question, could you please repeat that? The last, I think I answered all the parts except for the last one.
Yeah, the last one, your evaluation between the economy and benefits and the technique. Now, is the technique is available for you with the economy side, or it is expensive, or it is cheap? I don't know. Did you compare between the existing technique and your proposal techniques? Do you have any evaluation for that?
Yes, in terms of using nanoparticles, actually it's been used in the pilot phase in many countries, mostly in America, but in here, I don't have much data, but it tends to be more conservative in this area. So this is a very risky business. So to introduce a new technology, we would need to invest a lot of research and pilot phase testing in the field to ensure the validity of this technique. It was done on the other side of the world, and it proves very positive, significant results. However, in terms of what could be done in terms of the economics, basically we're dealing with a lot of uncertainty. So any small problem or things, any small detail goes unnoticed can result in catastrophic result. For example, the Deepwater Horizon, some silly mistake resulted in the pipe collapsing and then causing the largest leak in the world. So this is a very risky business. We're dealing with a lot of uncertainty. So we try our best to mitigate those kind of uncertainty, execute everything to the accurate or actually precise as possible to avoid unexpected rescue problem. And yeah, so basically this is why one of the oil and gas companies in here in Qatar are welcoming, doing this, taking the outcomes of this project and testing it in a pilot phase. We're trying our best to come up with new ideas and technologies to solve current problems. However, it's very challenging.
Thank you.
Thank you.
Dr. Nader, I think you had your hand up.
Thank you very much, Mr. Reem. It was really interesting presentation. I learned a lot. I have, I guess, two quick questions. The first is about the decision to test kind of nanotechnologies and nanotubes as opposed to other mix-ins into the mud. Why did you decide to go in that direction versus looking at alternative technologies? The second one is environmental. When you first mentioned invasion zone, my mind went more to the water seepage and the effects on groundwater. But then at the end, you summarized that the main issues here related to operational problems and cost savings. Have you looked at the environmental dimension? Because there's a cost benefit to the environment. It seems like, less seepage using nanotechnology, but is there a compromise in terms of using that technology in terms of environmental safety and concerns? Thank you.
So for your last question, the two types of particles are environmentally friendly, so they don't cause any problem with that. Even the other components of the drilling mud, they are also tested before and confirmed by so many institutions, so that's fine if they were settled in the reservoir. It wouldn't cause any problem. The first question, could you repeat that?
The first question is why did you decide? It seems like the base mud is something that you want to improve on, and then you made a decision to explore nanotechnology. Did you also at the beginning in the brainstorming stage consider other kinds of techniques to improve on the mud?
Actually, no, because the nanotechnology is an advanced technology and it was tested in the West world. However, most of the literature are supporting the nano mud as it has better rheology characteristics, and it came with a lot of good results in terms of the mud stability, the hydrostatic wellbore pressure, etc. So we wanted to test how it it will improve the mud filtrate, and also compare between, see if there is a correlation between the formation porosity and the particles morphology.
Thank you.
You're welcome.
Dr. Khalid, did you have a question?
No, but I see Dr. Dina's hand up.
Yes, thank you, Dr. Khalid. Dr. Benedict, I just have one question actually. It's a very nice presentation, very well put together. And actually my question follows Dr. Nader's question, is the environment. You said it has been done in elsewhere. We know you did not pilot it yet in the real environment. Would piloting in the real environment have basically would you think it will influence the study itself and how it is, because it happens in the lab, now you're taking it to the real environment with an oil and gas company here in Qatar. How do you think the environment will affect your experiment?
I'm sorry, could you repeat your question? I didn't understand it.
So for me, I just want to know what, like, just to put it in a basic wording, what factors will, what environmental factors will impact your experiment when it's taken in a real world environment?
Actually, there are no environmental factors that could, cause some concerns or to be worried about, because all these components were studied before, and for the nanoparticles, they are actually from silicon. Silicon is basically like sand. So, and for the carbon, the hydrocarbons are basically made of carbon. So they are actually out of the, the subsurface, and then they are back to it. I mean, the element. So there wouldn't be any harm with it.
Thank you.
Okay. I have one question. I hope it's a fast one. What is the relative size of these particles relative to the disk porosities, which are 5 and 10 microns? And why are you seeing different results with those two different disk porosities? Can you explain that to me?
Could you please repeat the question? Yeah, I didn't get it. So you mean the difference between the screw sizes in comparison with for the ceramic disc, or why?
Yeah. So first of all, how does the particle size compare to the disc porosity size? Are they much bigger? Are they much smaller? And then why are you seeing somewhat different results with those two porosity discs? If you can just kind of take me through that briefly.
So basically, the nanoparticles are in nano size, and the porosity of the pore size of the disc are in the microns. So they are bigger by 10 to the power 3, -3, sorry. So, and when we compare that, basically, we have different results because of the particles' behavior. If that, for example, they tend to agglomerate, the nanoparticles have high surface to volume ratio, and they're very reactive, therefore they improve the mud properties. However, the problem is that they tend to agglomerate and settle very quick. So going through the small pore will make some problems, and it will be easier for the particles to agglomerate. However, in the larger pores, it will be easier to go through. Does that answer your question?
Okay, so if I understand that, so although the particles are very tiny because of the fact they're aggregating, they are behaving as if they're larger particles?
At some extent, yes.
Okay, all right. That's all I have. Any last questions from the judges? Seeing none, thank you very much.
Thank you.
Great, thank you, Reem, for a rich presentation. Lastly, we have our medical doctors in the making from Cornell Medicine-Qatar, who will present their project on determining the role of 2 genes in tumorigenesis and metastasis of lung cancer. Umna and Zainab, yeah.
Yes, thank you.
Please share your presentation. Yeah, please.
Are you able to see our screen and hear me well?
Yeah, all the judges are okay. Tamam, great.
Perfect. Thank you. So good morning, everyone. I am Umna Sharma, a Cornell medical student, and together with my colleague Zainab Al-Ansari, we'll be presenting a project this morning. So our project is on determining the role of 2 genes, lipocalin-2 and GPNMB, in the tumorigenesis and metastasis of lung cancer. So to begin by giving some context to our project, so first we wanted to look into which genes have a change in their expression in lung cancer. So we did this using the metastatic lung cancer mouse model we developed in our lab and used a technique called RNA sequencing. And through this technique, we identified some genes that had altered expression in lung cancer. And of these genes, we chose lipocalin-2 and GPNMB because these 2 genes are less studied in literature. Diving more into these 2 genes, so lipocalin-2 has been implicated in cancer. However, its role in the development of cancer is controversial. So from literature that has been published, we know that there is increased expression of lipocalin-2 in different cancers, such as breast cancer, ovarian, and pancreatic cancer, and decreased expression in colon cancer. However, in the context of lung cancer, there's very little known about its role. And therefore, we thought it'll be interesting to investigate what role does it play in lung cancer. Coming to GPNMB, there has been increased expression noted for lung cancer and breast cancer. However, the specifics about its role and the role it plays in the pathogenesis of lung cancer is very unclear. So this leads us into what were our goals for this project. So our objectives and aims for this study were to determine the role of lipocalin-2 and GPNMB on tumor cells, focusing on the behavior of tumor cells in lung cancer, specifically cell migration and cell proliferation, and then to assess, are these genes really necessary for the survival of these tumor cells and their metastatic ability to other parts of the body? And this will provide us to clinically apply our results to our patients in terms of, can we use these genes as markers for diagnosis, prognostication, or treatment targets for lung cancer? Now diving into more, how did we conduct our project? So as you can see from the schematic on the right, we had 2 mice models, the wild type, which was our control, and the transgenic, which was the mice model that had the cancer. So as you can see from this schematic, we're looking at the abnormal lung, and the white well-circumscribed lesion is the lung cancer. So using this tissue, we performed the RNA sequencing I mentioned just a while ago to identify our genes, and we chose lipocalin-2 and GPNMB. And from this tissue, we isolated our cell line for the lung cancer, which was E86. So our E86 lung cancer cell line was used as a baseline control. And from this E86 cell line, we overexpressed and knocked out the lipocalin-2 and GPNMB. So again, we had our baseline E86 cell line, and then we modified it to overexpress or knock out the lipocalin-2 and GPNMB. We then performed PCR and Western blot on RNA and protein respectively to quantify the expression of these genes for both overexpression and knockout. And then we further analyzed the tumor cell behavior. So for cell proliferation, we studied this using the MTS assay. So the MTS assay was done using a colorimetry technique. And in this technique, we analyzed the conversion of the MTS compound tetrazolium to a colored soluble product to quantify the viable cells. Then we studied cell migration using the wound healing or scratch assay. And this was done by inducing a scratch onto the cell plate. And then in different time intervals, we assessed how far did the wound close. And by assessing that, we were able to look at the cell migration. Lastly, we analyzed the metastatic ability of our tumor cells by looking at the tumor sphere formation. And this is a well-established technique in literature for looking at metastasis. And we did this so we seeded equal amounts of the cells on an ultra-low attachment plate. And this is important because if this were a normal epithelial cell, they would require attachment to the plate. So if you're using low attachment plates, the normal epithelial cells will not survive. But tumor cells have intrinsic mechanisms that allow them to evade this mechanism and survive even with very low attachment. So they're able to divide, proliferate, and form these tumor spheres, and thereby metastasize to other parts of the body. And now Zainab will talk more about the results and discussion.
Hello everyone, my name is Zainab Al-Ansari, and as my colleague mentioned, I'll be discussing our results and finding and then concluding our presentation. I'd just like to clarify that the results are split into those that determine the level of expression, because we needed to, of course, confirm that the overexpressors were in fact overexpressing and the knockouts were in fact underexpressing. And then the results that focus on the effect of these different levels of expression on the characteristics of a tumor, so the proliferation, migration, and metastasis. I'd also like to further clarify that we will be focusing on our results with lipocalin-2 and not GPNMB in the interest of time. Our results with lipocalin-2 were more significant, and the GPNMB findings can be found in the reports, and we would be happy to answer any questions on them. But essentially, with GPNMB, both the knockouts and the overexpressors had no significant difference with regards to tumor migration, proliferation, and metastasis. So we will be focusing on lipocalin-2. So as you can see, this first slide is essentially just clarifying that lipocalin-2 is in fact increased at a greater, is in fact expressed at a greater level in lung tumor tissue compared to normal lung tissue. So the left panel is showing this in terms of our quantitative PCR findings, which looks at the level of RNA expression, and the control is the healthy tissue, and the lung tumor, as you can see, had significantly greater expression of lipocalin-2 RNA. The right panel is looking at the level of protein expression using a Western blot, and you can see both visually that the protein band density was darker for lipocalin-2 in the lung tumor tissue, and this was then confirmed by quantifying it by normalizing this with the tubulin expression, which is seen in the chart below. And once again, lung tumor tissue did express lipocalin-2 at a greater level in terms of protein. This slide is now showing our quantitative PCR changes in the overexpressing cells on the left and the knockout cells on the right. So looking at the mRNA expression of lipocalin-2 in our two overexpressor lines, lipocalin-4 and 7, the lines below, compared to the E86 line seen here, you can see that mRNA for lipocalin-2 was in fact expressed at a significantly higher level. And the same is true for the lipocalin knockout cells. So the knockout was successful. Compared to the CRISPR scramble control line, you can see that knockout line 1 and 2 had a significant decrease in expression, approximately 80% and 40%. Moving on, we're looking now at the effect of these different levels of expression on tumor characteristics, starting with the effect on cell proliferation, which, as we mentioned, was studied using the MTS assay. You can see in the top panel, looking at the overexpressors, lipocalin-4 and 7, that there was, in fact, a significant increase in the rate of proliferation at the 2-hour, 3-hour, and 4-hour mark, compared to the control line. On the other hand, in the knockout cells, there was in fact a significant decrease in the rates of proliferation, once again at the 2-hour, 3-hour, and 4-hour mark. Now, this slide is looking at the wound healing assay, which was reflective of the ability of cells to migrate. So the panel on the left, you can see the images that show the scratch that was induced into the culture. And with time, you can see the wound closing as the cells migrate inwards. Now, in the overexpressing cells, all of them had completely closed the wound by 36 hours. And there was actually a statistically significant increase in the rate of wound closure seen even at the 17-hour mark. In the knockout cells, by the 36-hour mark, there was once again a significant difference, in the sense that there was a decrease in the rate of wound closure with the knockout cells. Moving on, this cell is looking at the effect of this slide is looking at the effect in terms of tumor metastasis, which was measured through the tumor sphere formation. So as you can see, we've shown the 4 times, 10 times, and 20 times magnification. The left column is looking at the E86 control baseline tumor cells. And you can see that they form these structures, which are the tumor spheres. If you look to the right 2 columns, which are the overexpressors, this was where we saw an interesting and somewhat unexpected results, in the sense that it was actually, it weakened the ability to form tumor spheres. As you can see, the tumor spheres were significantly smaller, and they were mostly composed of dead or dying cells. And this essentially says that there's a significantly increased level of expression with the lipocalin-4 and 7. The ability to form tumor spheres is weaker. So now I'd just like to discuss and briefly conclude our results. Overall, expressing lipocalin-2 at a higher level increased cell proliferation and migration in lung adenocarcinoma tissue, whereas knocking down lipocalin-2 had the opposite effect. It decreased cell proliferation and decreased migration. Furthermore, overexpressing lipocalin-2 actually reduced the formation of tumor spheres, suggesting that there is some basal level of lipocalin-2 expression that may be needed for metastasis, but overexpressing beyond a certain threshold, which was seen in the 4 and 7, actually leads to impaired ability to form tumor spheres and metastasize. On the other hand, knocking down lipocalin-2 did not seem to affect tumor sphere formation. There was no significant difference seen with regards to the E86 line. Overall, despite there being increased expression of GPNMB in lung tumor, we didn't see any significant change in terms of cell migration, tumor sphere formation, or proliferation with different levels of GPNMB expression. And we concluded that elevated lipocalin-2 expression enhances tumor pathogenesis in the local lung region by increasing rates of cell proliferation and migration. So within the local tumor environment, it does contribute to tumor pathogenesis, but it does not contribute to the metastatic potential of these cells. And furthermore, we also concluded that the observed increase in GPNMB expression in lung tumor compared to healthy tissue is more likely to be a consequence of tumor formation, as it didn't seem to significantly contribute to the tumor characteristics that we discussed. currently, the lab is examining the role of lipocalin in the epithelial to mesenchymal transition, which is a known mechanism of tumor spread and metastasis. And we are looking at the role of lipocalin-2 in that. We would just like to thank the Qatar National Research Fund for making this study possible, as well as those who helped us in the lab, Ms. Dania and Ms. Raja. We really could not have done this without them. And now we'd be happy to take any questions.
Questions from our judges? Khalid.
Can I ask a question? Yeah. So nice work, guys. Can you go back a couple of slides, or 3 or 4 slides? Yeah, more. Yeah, right here. Sorry, next slide. Next.
Right. Okay.
Yeah. So your overexpression cell lines, right? So LCN2 relative mRNA overexpression is only about 10-fold, whereas LCN7 is like 180-fold, right? Is that correct?
Yes. Yeah.
But the effect in vitro seems to be non-distinguishable between the two. Right? If you go to the next slide, right? Those two cell lines seem to be proliferating at approximately the same level. So can you explain that? I mean, do you have a model to explain why the results? I mean, it's almost like, you know, one could argue that lipocalin-2 has no effect on or the abundance of lipocalin-2 has the effect of lipocalin-2 is non-linear on cell proliferation. Is that the right conclusion to make?
Right, so this was actually a really interesting finding, and I'd just like to go back to the slide to help clarify this. So while both of the lipocalin-4 and 7 were expressing the mRNA at a significantly higher level compared to the control line, but as you can see, lipocalin-7 in terms of mRNA was overexpressing at a much greater level. But interestingly, in terms of Western blots, which we haven't shown on the screen, the difference in protein expression was much smaller. So lipocalin-7 was still overexpressing protein at a greater level than 4, but only moderately. And we suspect that this may have been because of differences in the protein stability or in the RNA or in the mRNA translation process. We're unclear exactly. It would be interesting to study it further. But essentially, in terms of proteins, they were expressing at a much more similar level. And that could be the possible explanation for why the difference in proliferation was closer.
Is that protein expression in both cases significantly higher than control?
Yes, yeah, that's why they were deemed acceptable to use in the study, because both of them were still overexpressing in the range of 3.3 to 4-fold compared to the baseline A86 cells.
I mean, you should include that data here, right? Because that's a very important data point. Okay, so another question I had is, you know, again, I find it curious, as you said, that lipocalin-2 does not drive the formation of you know, tumor spheres, which is kind of surprising, because if you think this is driving tumorigenesis, then it should be doing that. So can you, I mean, have you looked at public data sets, for example? There's a lot of public RNA sequencing on you know, all sorts of tumors, both pre-metastatic and metastatic tumors. To look at the expression of lipocalin-2, what is it called, GNMB, to see if they sort of fit your model, or if there's something funky going on with your experiment.
So in terms of the RNA sequences from the public database, we did not investigate that in our project, but that is a great suggestion. That's something we can look into for future studies. But more specifically into our project, so lipocalin-2.
I think somebody muted you while you were talking.
Am I unmuted now? Yes, okay. Okay, I guess I'll just start with my explanation. So in terms of in terms of your RNA sequencing in the public data set, we did not look into that because our project did not investigate the public databases for the different sequences, but that would be an interesting point to look into for future study. But in terms of lipocalin-2 specifically and its role in tumorigenesis of lung cancer, so like we mentioned, there was overexpression noted for cell proliferation and cell migration. In terms of tumor spheres, there was a decrease, which suggests that it plays more of a role locally in the lung environment rather than spreading to other parts of the body, which is why this was an interesting finding for us. So it does likely contribute to metastasis at a certain threshold, like
I suppose, yeah, so just to clarify, the E86 line itself does already have, because I think you mentioned that it seems almost contradictory for overexpression to decrease the ability to metastasize. But the E86 cell line, which is the control, does already have increased expression of lung. So it's already higher compared to normal lung tissue. So the difference with the 4 and 7 lines was that it was even further increased. So what we suspect is that there's sort of a threshold value, and above that threshold, that's where it becomes detrimental to metastatic ability.
So just as a final comment, I think it would help in these kinds of presentations if you showed, one of those like pathway slides that shows where lipocalin works in a specific pathway, what it interacts with, what it activates, what it inhibits, what other known tumorigenesis factors are involved in that regulation of lipocalin.
Right. Thank you. We'll make sure to include that next time.
We will keep it in mind for future presentations.
I have I think a simple question. Were your the lipocalin knockouts, were those true knockouts or were those just knockdown experiments? And the reason I ask is because even in one of the knockouts, you were still getting 40% expression level. And so can you explain to me if it's knocked out, why you're still getting fairly significant levels of expression, or transcription at least?
Oh, yeah. Thank you for that question. So yes, so the thing is, so the cell plate that we used, this was an interesting finding that we saw as well, because we would expect complete knockout for the results, but we did not have a complete knockout because we found that our sample wasn't fully purified. And this was something we're planning to work on, but because of COVID, we weren't able to continue our work in the lab because the labs were suspended. And it's something we're looking to work on currently when restrictions are being lifted. This is why we did not have a complete knockout. And more specifically diving into the knockout procedure, so we used transduction, which is a lab technique where you you insert the plasmid into the RNA using a lentiviral vector. And this is how we knocked out from the baseline E86 cell line. But the reason why we didn't have a complete knockout was because our sample wasn't completely purified, and our work to do so was impeded because of COVID. So we had to work with the data we had.
Great. Okay, have there been any outcomes of the work? In other words, has this been presented at meetings or published or any such outcomes?
Yes, so specifically for our project, actually we are writing up a publication to be submitted to a journal very soon. And we're gathering the data from the epithelial to mesenchymal transition for lipocalin-2 that Zainab mentioned, and also the purified sample for the knockout for the lipocalin. And once we have that data, we will be submitting it very soon for publication, but it's already in the works.
Thank you. Any other questions from the judges? Seeing none, thank you very much.
Thank you.
Thank you, Omna and Zainab.
Thank you both.
Ladies and gentlemen, that is a wrap for today's presentations. The diverse topics covered in today's presentations reflect QNRF's commitment to advancing research in all fields of science in Qatar. The judges panel will be leaving us now to finalize the results. Meanwhile, for us staying in the event, please join me in welcoming Dr. Aisha Al-Abeidli, Director of Capacity Building at QNRF, to announce the winner for the best representative image of an outcome competition, BRIO 2021. Dr. Aisha, the floor is yours.
Thank you, Noor. Colleagues, ladies and gentlemen, our dear students. Sorry. A very warm welcome and good afternoon to all of you. Before moving and to announce the winners of the best representative image of an outcome competition, I want to take a moment to recognize our exceptionally talented young researchers. I'm thoroughly impressed by the presentation given by our UREP awardees, which paint a very promising picture of the future of the RDI ecosystem in Qatar. An appreciable point I have observed in the presentations made by the UREP contestant is that they have taken an interdisciplinary approach in conducting the research projects to solve our increasingly complex global challenges. Beyond the various laboratory tests, lengthy sequences of data, and going through volumes of existing knowledge, research has an often overlooked side which can help people outside the academic and scientific research community learn about the projects and connect with it in a unique way. And that, my dear colleagues, is the artistic side of the research. When you put art and science in the same sentence, the normal response would be to think of them as antonyms that are on distant and divergent paths from each other. However, the truth cannot be further from that. In fact, art and research have much more in common that we tend to think of. To begin with, both are rooted in the process of observation and trial and error. Similarly, both provide us with a window to see that there is a lot more in this universe than what we can see with our eyes. Similarly, be it a captivating art piece of high-impact research outcome, both capture and convey the brilliance of the human mind and are a testament of one's skills, intellect, and imagination. To celebrate this and bridge the gap created between art and science, we launched the best representative image of an outcome or a BRIO competition and dedicated it to encourage our funded researchers to exclusively feature the artistic outcome of their research and gain recognition for it. Ladies and gentlemen, just like our research and academic community, the BRIO competition has been successful in garnering interest from the members of the general community. This year alone, almost 3,000 people voted for the 8 competing images shortlisted from a pool of 34 submitted images to pick the BRIO 2021 winner. So let's have a look at this year's competing images, which you will see on your screen now in no particular order. The first one is foam bubble surface structure by Dr. Naif Al-Yafi from Texas A&M University at Qatar. Next up, we have polymeric nanoparticles for H2 generation from H2O by Malak Hilali and Dr. Mohammed Al-Hashimi from Texas A&M Qatar. Our third contestant is Abirami Sataban and Dr. Chiara Cogno from Sidra Medicine, whose image is titled A Cell Bouquet. Now an image by Dr. Sumaya Al-Maadid from Qatar University, which is titled Non-Cancer Photo in the Middle of a Cancer Photo. We are halfway through now. We have an entry titled The Many Faces of Stargardt Disease by Saoud Al-Khuzai, a GESRA student at Oxford University. The next image is by Padmini Sarajandra and Dr. Isra Mar'i from Qatar Foundation, and it is titled Valve Endothelial Cells. One more image from Qatar University by Dr. Anshu Ashok and Dr. Anand Kumar, titled Copper Nanoflowers as Glucose Biosensors. And our last competing image has been sent by Dan Al-Ansari and Dr. Haytham Abu Saleh from Qatar University, and the title is Smooth Muscle Cell Cytoskeleton. For those of you who had not voted, you must have a favorite now, and we will see now that based on public voting, who is the winner this year. So without any further ado, we will now announce the first, second, and third place winners for BRIO 2021. With 15% votes, the third place goes to polymeric nanoparticles for H2 generation from H2O by Malak Hilali and Dr. Mohammed Al-Hashimi from Texas A&M University at Qatar. Congratulations to Tamouk. And the second place with 31% of the total votes, Copper nanoflowers as a glucose biosensor submitted by Dr. Anshu Ashok and Dr. Anand Kumar from Qatar University. Congratulations, Qatar University. And now it is time for the moment we have all been waiting for. With 35% of the votes, the winner of the best representative image of an outcome for the year 2021 is the cell bouquet submitted by Abirami Sataban and Dr. Chiara Cogno from Sidra Medicine. Congratulations to Sidra Medicine. Congratulations to all the winners, and I thank all our participants this year. With your enthusiastic participation and the support of our audience, we aim to keep delivering successful future editions of the BRIO competition. Thanks once again, everyone, for being here with us today and for joining us in celebrating the artistic side of research. Thanks. Back to Noor.
Thank you, Dr. Aish. Thank you. Thank you for your illuminating remarks, and congratulations to Sidra, Qatar University, and Texas A&M for winning the BRIO 2021 competition. Ladies and gentlemen, we will now commence with the announcement of the results for the 13th annual UREP competition. Everyone here is a winner today, and as I said earlier, qualifying for this competition is in itself a remarkable achievement. We will now start by announcing the winners for the poster category. And before doing so, I would like to take this opportunity to thank all the 16 poster judges for their time and effort. Without them, we couldn't have had smooth and successful sessions with the contestants. Now for the results that you all have been waiting for. Third place goes to project from Qatar University presented by Dua, Dina, Hadil, Aya, Sumaya, and Aisha. Congratulations, and congratulations to your mentors, Dr. Haytham Abu Saleh and Dr. Isra Mar'i and Professor Christopher Trigo. Congratulations. So next to the second place. The second place goes to project about recycled materials from Qatar University. Congratulations to Rashid, Mohammed Khalil, Usama, Umar, and Wardan. Congratulations to your mentors, Dr. Wa'il Nahal and Ala Taha. And now for the first place. The first place goes to Cornell University with a project titled Humanizing Resources and Rising Employment Opportunities for Qatar. Congratulations to Abdurrahman and Khalsa and to their mentors, Dr. Sonia Alonso and Zahra Bab. Congratulations. Congratulations to all the winners of the poster category. We are to move on to the oral presentation results, but seems like the competition is super high, and I think we have to give it to our judges, as they might need some extra time deliberating with Dr. Mohammed Al-Kuwari. Yeah, thank you. And therefore, I would like to invite you to enjoy this short video of our previous year competition. Please bear with us, as expected, the competition is super high, so let's just give some more time to our judges. I hope the wait has added to your excitement to get to the final results. So it's time to announce the winners for the oral presentations. We saw some quality presentations today, and I'm sure our judging panel must have had a hard time deciding today's winners. So let's see what their final decision is. I know it's a virtual event, but still we need to feel your energy, contestants. So the third place goes to the topic titled "Study on the Influence of Nanoparticles in the Filtrate Characteristics and Filtrate Cake Formation of a Water-Based Drilling Fluid" from Texas A&M, presented by Reem Ad-Dosiri and her colleagues. And congratulations to you all and to your mentors, Dr. Mahmoud Amani and Dr. Anoub Baby. So for the second place, the second place goes to, drum roll. It goes to Cornell Medicine with the topic presented by Zainab and Omna with the mentor with the research mentor Dr. Nisreen. Congratulations. Congratulations. Congratulations to all the winners and their mentors, and we wish all the students best of luck in their future endeavors. And thank you all for joining us today, and very special thank you to our judges for helping us with the success of today's event. The UREP competition is a team effort, and we are grateful to everyone who helped organize today's event. Congratulations to all the winners, and see you in future events, inshallah.
Inshallah. Well, take care.
Thank you all.
Thank you.